And welcome everyone, I'm Philippa Jefferies and I'm here with Rajeev Prasad, also from Cybersecurity magazine. And today we're talking to Ahmed Banafa, professor at San Jose State University. He has a forthcoming book titled Quantum Computing and Other Transformative Technologies, which explores quantum computing as a transformative technology and its applications in communications, cryptography, teleportation, IoT, and many more. And it's these topics of transformative technologies and security that we are discussing today. So welcome both of you, welcome Ahmed, thank you for joining us today.
Thank you so much. I really appreciate this opportunity.
Hey, just to kind of get us going, could you please start by introducing the book and the motivation and kind of the topics it covers a little bit?
My focus in research on three axes and three tracks. Actually, basically, if you want to count what we have now, it's actually four of them that they are very active. The first one is the blockchain, the artificial intelligence, cybersecurity, and Internet of Things. Now, all of those four technologies used as we speak, and they are advancing, and we have a lot of new development in them. But there is a big problem approaching all the four technologies, which is the quantum computing. It's going to create a big challenge for them. Because if you talk about cybersecurity, artificial intelligence, IoT, blockchain, you're relying heavily on encryptions. And encryption can be easily solved by quantum computing, something that you need 10,000 years to process to solve. Quantum computing can have it in 300 seconds. So all what we talk about it is really there is a risk on everything we're doing that's going to be exposed, and this is why quantum computing is gaining attention. It's not a new topic, for everybody. We heard about it before. It was like, from here and there, you heard some small bits, and pieces here, but now it's serious.
Okay, and the title of the book is kind of Quantum Computing and Other Transformative Technologies. Is this kind of what you're meaning by the term transformative in this case?
It's a very good question. The quantum computing is transformative in a sense of we're going to have something called, post-quantum computing and pre-quantum computing. So everything we're doing before the quantum computing becomes something which is, I can go to Best Buy, I can go to stores, I can buy it online, a computer as a quantum computer, quantum laptop, quantum desktop, quantum smartphone. Then you're gonna draw that line. That's gonna be the case. That's the case for that. The other transformative technologies, something like effective computing, which is talking about emotions. Nowadays, when we talk about AI, we're talking about AI not just something that will save me time and do the task. There is this new term. We're going to humanize the robots. We're going to make them act like human, understanding our emotions. I was given an interview to one of the local stations and TV station, and I was talking about how now we are going to get to the point where car is going to talk to each other. So if I'm driving a car and the car next to me, there is a guy or a girl or somebody's inside it, they're upset, then they're going to warn me, slow down, let them go, or they have a gun, or they have some argument, so the cars will start communicating with each other in a sense where it's going to be looking at you as, as your assistant. Computer going to shut down when you're tired. They're going to say, enough. You cannot do more than this one. You can do this one tomorrow. Cars going to stop working and moving if somebody is intoxicated. So this is part of the effective, computing. Another technology is edge computing, which is something that is very common now because look at Netflix, look at HBO, Plus, look at or Max, look at all of the different streaming that you have no idea which show will be more popular at a certain area. Normally, we have cloud computing where they have big data centers in different places. And you have one in Finland, one in Denmark, one in Minnesota or Wisconsin, and one in in the places where it has to be cold. That's because they need to save on the energy. Now we're going to have small data center next to where the action is. We anticipate that there will be a lot of demand going through this. And in the book, and also I'm talking about security, how the security was a big issue here. I covered the blockchain, and I talk about the blockchain in detail. I covered the IoT, and also I have it in details. Now, the book ends with the concept of the metaverse, which is, I mean, it's picking up steam. People are wondering what it is. How is that going to help us? It's going to take another 10 years. So this book is for 10 years from now. That's how we look at it.
So it's quite fascinating, and thank you for sort of depicting your two previous publications. By the way, these were bestsellers as well. Into a connectedness, and how quantum computing, this particular book that we'll be publishing with you, would be the underlying technology of blockchain, IoT, and everything that comes along that ecosystem, to sort of graduate into the or to evolve into the next phase of delivering more intrinsic experience to whoever the users are. What fascinates me particularly is how, and this is a question as well, how do you foresee, how does one actually start educating new engineers into sort of working towards a vision that in all intents and purposes would actually happen? It certainly seems like it, with all the investments by industry and governments across the world. So could you talk a little about that? How do you see the education, at least in the US, because that's where you're based, how would it be picking up?
I mean, the use of the technology is a must now. I mean, it's not even some kind of a luxury thing. I'll give you a simple example of this. Almost every student, they have a smartphone. So now that will be the way of, adding some of the, for example, apps. I mean, there was an app, called Somi, and that app is a fascinating app because that brings the families and the educator and the student together, and they can have some kind of project and imaginations, project and drawing and everything. And this is all because of this app. This app is available for they have about 10 million subscribed to that. 75% of the schools of the United States, they have it, K to 12. This is technology. This is using this kind of apps to communicate ideas. In the past, I would have it on a piece of paper. How would I know that your son or my son or your daughter or my daughter is creative? Give them the tools, and they're going to show you if they are creative. Now, the next level is when you talk about the VR and the AR and the XR. And that will be the stepping stone to get us into the metaverse, or the virtual world, where I'll be sitting here and all of us, three of us, will be in the metaverse where I'm an avatar, you're an avatar, and Philippa is an avatar. And then we're going to pick and choose what avatar we're going to have. We're going to pick and choose what offices so we're going to interact in a parallel universe. And this is good because, number one, it's going to save a lot when it comes to expenses. We have a taste of this with the pandemic, when everybody sat home, and they found out that they can actually do work. They can finish a lot when they are using basic tools like Zoom or Meet or Google, or a Microsoft meeting or whatever, you use it there. They found out that, yeah, I still can do. I can have the whiteboard, I can share the screen, I can have the PowerPoint. I don't have necessarily to spend, an hour on the road just to get to a place where I can do exactly the same thing, where you can have this. It's going to add that depth of the human interactions. Now, I talk to you, both of you here. For me, you are squares in front of me, and I'm a square in front of you. And if I turn right and left, there is nothing. But in the future, I can turn to the right or left and talk to you, and I can see your body language. This is going to be the next level. And we've seen this in the sci-fi movies. So that is the direction for the education, which is the introduction of more of technology. And this technology will make it easy to communicate with the students, make it so easy for them to be creative, to understand difficult concepts. I can have this, virtual object in front of you. We can open it, we can turn it around, we can have it clear to you. So instead of go and buy plastic model and pay that money, and it's and it's going to be obsolete within 2 or 3 years.
Okay, great. Thank you, Anne. And just to kind of bring it back once again to topic of the book and what we're discussing today, which is quantum computing. We've already kind of talked a little bit about some of the possibilities that this could bring equally to some technologies that we have at the moment, AI and so forth.
Right.
Could you just give your thoughts on kind of where we are now with quantum computing? How realistic is this when you talk about that kind of pre and post quantum computing world? Like, when could we expect that?
We still, far away from getting to the point where quantum computing will be something which is an appliances that you can buy and get it. Just to give you an idea about what is the timeline here, quantum computing defined by qubits. A qubit is similar to the bits, which is zeros and ones. In the case of quantum computing, you're talking about 0, 0, 1, 1, 1, 0, all the combination happening at the same time. I remember one time, a host show, they asked me to give an example about quantum computing compared to classical computing, and that show was actually from South Korea. It's called the Busan Waves. Busan is a beautiful city in South Korea, and I told her, okay, think about it this way. Let's say that you have a maze, you enter a maze and you have doors everywhere. In order for you to get out of that maze, you have to open the door, go to the next door, next hallway, next door until you get to the end. In the case of classical computers, you have to open door after door after door. You could have a dead end and then go to the next door until you get to the end. If we use the quantum computing to solve this problem, you open all the doors at the same time. So you see how easy for you to get your way outside. And that is the simplest way to look at quantum computing. Now, the other technical part of quantum computing is how many qubit technically we have today, practically. IBM, they're talking about 400 qubit. In order for me to be worried about encryption that can be broken, I need 2,000 qubits. So we're still far away from that. Even if the growth is exponential, still you are talking about many problems associated with quantum computing, like noise, like interferences, temperature. All of these things has to solve it before you can get to the level where it is a box you can buy. So within 10 years, 20, 30, I'll be surprised if we don't have a computer that has good number of qubit that will solve a lot of problem. You can buy now qubit, the computers with 3 to 4 to 10 qubits. The Chinese, are in the market for that. There is one in Canada that can, I think, up to 53 qubit that you can buy it, but still it is a big, huge box. It's like the, it's like the computers when they started at the beginning. They're just the whole room.
So they're not ready to replace the PCA, if you like.
No.
Or, okay.
No, it's not yet. It's not yet, and it's going to take a while to get this done, because the quantum computing has multiple tracks. There's some of them you can see them hanging from the ceiling with like a copper or a golden. Those are really very sensitive to the temperature, to the interferences, so many things going on. There are other designs. They're trying to have other design which is not going to be as sensitive as this. Google has its own track. IBM has its own track. There is the Canadian company has its own track, and NASA is working with Google also on making sure this is available for us. But until we hit that 2,000 qubit threshold, the encryptions are safe.
Yeah, I suppose the other side of the argument is that this tool in the hands of the hacker is possibly is as powerful as the security it provides.
Correct.
User.
And fascinating about this, Rajeev, is they found out that some of the government and some of the hackers, the professionals, they're stealing the data and they're keeping it until we get to the quantum computer, and they're going to break that encryption. This is how far they're looking at. We're going to keep this data. We know this is very important. This is not going to age over time. So until we get to that level where there is a technology will help us with it, we're going to use that technology.
Right. So both sides of the both sides of the players, if you like,
Correct.
are sort of vested in this. So I'm just curious, how do you see the whole IP in quantum computing being distributed globally? I mean, who are the major players? Do you see more private sectors or government actually taking ownership of this?
As of now, it's the interest of the private sector more than anything else. Google is making a lot of waves. In 2019, they announced they have something called quantum supremacy. Quantum supremacy defined by by a simple principle, which is if a calculation that will take 10,000 years, if you can do it in few seconds, which is 300 seconds in the case of Google, then you achieve the quantum supremacy. IBM is disputing that big time. They said, no, we did not receive that. There are a lot of Chinese companies that really doing it on a small scale. The governments, they more focus, if you talk about the government, focus on supercomputers. They focus on having huge supercomputers that it just can work now. The funding is there for the quantum computing. Classes about quantum computing start to spreading in many of the universities in the United States. At San Jose State, there is a quantum computing, but it's a graduate class, which means you have to finish your bachelor degree and have enough math and physics to do it. And in other universities, they have an introduction for the bachelor degree just to understand what is quantum computing. I want to add one thing here just to see how fascinating is the concept of how we progressed in computing. The current computers we have now based on math, which is something called Boolean algebra, which is basically zeros and ones, you add them. We actually achieve, or we hit the maximum we can get from the math. So we jump to the physics. Quantum computing is built on physics, which is quantum physics. The next step is biology. So the next wave of computing will be the biocomputing, which is now, and everybody probably heard about this, the DNA of the human being has a huge storage, and it's so complicated that it is a perfect candidate for the third wave of computing. After we're done with the physics and we achieve everything about physics, we're going to go to biology. Maybe after this, we can go to chemistry as the basis for the computing. So the engineering is using all the levels of science to advance it and have applications. And that's the next natural thing for us, to use the physics after we're done with the math.
So certainly everything in our lifetime, right, Ahmed?
Okay, perhaps as we are a cybersecurity magazine, perhaps we can talk a little bit about further about the possibilities that quantum computing would hold for cybersecurity. Rajeev, you already mentioned the possible risks with attackers using this kind of technology, but Ahmed, perhaps you could talk a bit more about the benefits we could see as well.
In new encryption techniques, just to understand how that will be different from whatever we have. The hackers, when they access or intercept the communication, they get the data, whether it is by intercepting this at a certain point and grabbing the information, filtering the information, and that's fine. Between the sender and the receiver, you can get that process. If we are using quantum computing, the minute you intervene with the communication is changed. So there is no way for you. The concept quantum physics really plays a big part of it. If you try to find the location of this, bits we are talking about it, they're going to change their location and the whole communication is gone. So it's worthless. It's not what we are talking about. It's something else. So that's one part of it. And that can be reflected on many things. For example, the government is working heavily, I'm talking about the United States Department of Energy here. They're working on the funding for over $600 million for the quantum internet. And quantum internet, the competition that they have with the Chinese, that the Chinese already established something called quantum communication between 2 points. And the speed is unbelievable. At the same time, they're using the concept of entanglement. And the concept of entanglement is, another fascinating concept of quantum physics which if two particles let's say that they intercept or not intercept, they crossed the road of each other, and at any point in time, and they each one of them go to a different location, they still connected, but they go to the opposite side. So for example, if I turn this one left, the other one will go right. If I go up, go down. That's communication. That's basically what you do with communication, and it's used. And I remember, and this is really a story that I still smile when I remember it. Is I wrote an article about quantum internet, and I published it, and then I received a call from a professor at MIT. He was upset because in that article I stated that no matter what's the distance, if they are at the end of the universe, that particle itself, they still connect the entanglement, which that defy the concept of speed of light. And it was a big argument. Another professor from Berkeley was with us on the same, exchange, and until I gave him the sources of my calculations of mile, and he calmed down. He said, "Okay, I understand that now," but that could break the first law we have, which is the ultimate speed is speed of light. It's not proving yet. I mean, I make sure that this is clear to everybody. But if the distance is not an issue here, then we have to talk about speed, and this is why you get it to this point. So this is an example of the internet, the quantum internet. The other one is teleportation, and we see this one in Star Trek. And how can you go from one place to the other? They did that experiment. There's a university here in the United States did this experiment, but we're not talking about human, because it's going to alter all your cells and things. But you can actually send one article to or particle to another place immediately through the teleportation. So it's possible. Quantum teleportation is possible. Baby steps. We're still at the beginning. It's like sci-fi. But if you think about it, everything we have now is basically started with a sci-fi movie.
Exactly. I was hoping you could talk a little bit more about the quantum internet. So for people who may not have heard this term before, could you just kind of explain what you mean exactly by that?
Replacing the routers with quantum routers that will deal with the particles instead of dealing with electrical signals. The lines themselves, we were talking about all those fiber optics, and now we're talking about photons, as an example for the particles used in quantum computing. So the infrastructure itself will be different. We're not going to use anything what we are using here, because everything here is based on electrical signals, electromagnetic signals. We're not going to use that. That's the quantum internet will be a completely new revolution of what we have now. You and I understand that we don't do things by switching suddenly. There will be like a time where you can phase out what we have as the current traditional internet, and then we're going to have the quantum internet, and that will be an opportunity for something called the first mile and the last mile. First mile is when you are talking about, okay, I have a traditional internet, convert it to quantum signals, send it through the quantum internet. That's the first mile. When somebody receives it to who he or she has a traditional internet using the infrastructure of the quantum, then you're going to go to the last mile, which is go from quantum to the electrical, and this is how you get that information. So there will be a lot of changes. I mean, just look at what happened with the computers, what happened with the technology, what happened with the smartphone, what happened with the pagers, what happened, how we phase it out by having something way much better and faster.
Yeah, that's very interesting. So earlier on, when you described the different phases of computer life, as in the way it is where we are now, moving to quantum, next being biology as a possible third wave of computing, it makes me wonder about how the standards would be developed, who the actors would be for when we reach that point. I wonder if there is any standards activities going on towards quantum computing for the moment. And yeah, and who are the players besides the obvious, right? Who are the other unexpected players who are stepping in? Because obviously there are others who are realizing the same sort of path, life cycle, and they all must be trying to define their role in this industry.
That's correct. And it's a very good question, Rajeev, because standardization is always an obstacle, because when you say standardization or creating standard to the companies, you're asking them to make less money. For example, I'll give you just a simple example you can apply to quantum computing, IoT, Internet of Things. If you look at Alexa, if you look at Siri, if you look at Google Assistant, those are really hubs for the Internet of Things devices. You will, for example, if you have a new car, they're gonna say you want to have it Android or you have it Apple. Basically, that's what they're talking about. Many times you're gonna see some of the devices. This is Alexa compatible. Now, Alexa itself as a device is a very expensive device, but Amazon is almost giving it to you for free. Even you see it, sometimes they have it to $50, $23, almost free. The R&D spent in that device is just, amazing. They want to establish the hub where later on you're going to go and buy the devices that's compatible with this, and they can recoup their expenses. And it's working. When you talk about Alexa is dominating when it comes to the compatibility. The same thing goes with Siri. Okay, so can I use Siri? Can this talk to Siri? Same thing with Google. Same thing, with the different companies. So this is a fight of standardization. Amazon, they say we're going to have Alexa. Google, they say no, we're going to have the Android, as the Google Assistant as the rule here, because if I set up the standards, everybody will be using my devices, everybody will come into me, I will make money out of it. And this is where you have these non-profit organizations like the IEEE, the W3C, all of those big organizations, the government having something close to the ISO 9000 concept, where you're not going to do business with me until you're certified. And that's going to be the fight to get it when the market start growing. When everybody has their own protocols, everybody has their own, operating systems, everybody have their own, software, then they're going to say, okay, well, wait a minute, this is not talking to this, this is not talking to this, how can we deal with that? And you mentioned a very good point, Rajeev, about, about this topic is, we talk about quantum computing as a hardware. We need software. We don't have the quantum software. We don't have like something called quantum applications. We look at it as just crunching numbers, just run the numbers. That's not the only thing we expect from quantum computing. I look at it as there will be an operating system, a quantum operating system that will be running on the machines, and that's another field. Google is racing to get there. IBM is racing to get there because they want to build the first operating system and everybody can use it, dominating the market, and there will be the applications for that and how this application will help us. One of the applications we mentioned is the quantum internet, just to give you an example about how big is that field.
Yeah, unfortunately, coming to the end of our time, but I was just wondering, you talked a lot about kind of how transformative quantum computing will be, how it will change many things. I was just wondering what your thoughts are on kind of whether it will change the way we approach this kind of security, like internet security, or whether we'll be kind of using similar methods, but obviously adapted for quantum.
Security will be one of the biggest headaches and one of the biggest opportunities when it comes to quantum. That's why you're going to see the university, they already start talking about quantum computing. You're going to see that the word quantum is, coming up, multiple times, people talking about the field. It's because the complexity of the science itself, the quantum physics, and also the defying logic when you talk about, I can be in two states at the same time. I mean, the famous example always talk about Harry Potter, when you'll be in two places at the same time. This class and this class. Now this is where you have to create this army of engineers, scientists, professionals, technicians, that they will have the foundation, so we can go to the next level and say, now we're going to have a security professionals who will understand what does it mean. I mean, I cannot go and use a ping, tool to see what if that quantum router is working or not, or if that quantum computers will be different tools. So creating a new market, a new industry, and seeing this kind of new technology coming up with all the tools, with all the goods and the bads, with all the professionals, it's a matter of years. So you will find that within 10 years, we're going to realize how dangerous is this one. The experts are going to say, okay, we have to do this and this. We have to shut down this. We have to have an anti-quantum virus. That's, for example, an anti-quantum spyware. So it's just add the word quantum to whatever we have. We're going to see exactly what we did with smartphones, smart TVs, smart, cars, smart homes, smart cities. We just added the term smart to define that this is the next generation.
Okay, fantastic. And we're definitely at the end of our time now, but I just want to open it up. Ahmed, if you have any final thoughts on the book or what you'd like people to take away from it.
I look at it as, enjoy the ride. It's going to be really interesting and defying to everything we think about it. And speed will be not an issue anymore. It's a matter of, when. It's not how long going to take you to do that. We're not going to talk about how fast this, download, upload. It's, teleportation will be a possibility. Hopefully it's going to get to the case of the human. Now it's going to be a nightmare for the government, because now you're talking about passports, you're talking about crossing the borders. Now we're going to talk about the whole social, culture, political issues associated with this kind of technology, and it could slow down the advance here. But they cannot stop it. Nobody could stop the internet. Nobody can stop the quantum computing.
Okay, great. Thank you so much, Ahmed. Thank you also, Rajeev, for joining me.
Thank you.